Yeah. So now I'm recording this lesson. So we are going to dimension ducts. We're going to design duct work. Dimension, I remember last year I was, we were calculating ducts and we were dimensioning those ducts. It's, according to the comments, it's not the most exciting topic for the students. So I decided to change it, and we are going to work with REvit. Maybe it's not the most exciting topic either, but let's try to work with REvit in order to dimension ducts. These calculations, these hand calculations for ducts are tough. So last year we used an Excel file, and with an Excel file we can, yeah, it's getting better, it's less work. But I think with REvit, it will take time to model the REvit file, but once we have the REvit file, we can run all these calculations immediately, and we can make changes, and we can make it work. So we are not going to use hand calculations. We are not going to use Excel files. This year, we're going to use REvit even to calculate and to dimension those ducts. First and foremost, we need to, I think we need to be aware that ducts are not ugly, or they don't have to be ugly. So nowadays we have a lot of exposed ducts for supply air and for return, and people like it, especially in industrial buildings. People like it, okay? So why not? Why can't we use ducts as a design decision? We can expose ducts as a design decision. We tend to, when I was a student, doing this, it was like crazy. Well, you are going to expose ducts, you're crazy. No, you have to hide it. You need a false ceiling, and we need grills. Yeah, we need our diffusers attached to the false ceiling because we need to, well, we need ventilation, and yeah. But ducts, no, they are very ugly. But nowadays, if you use stainless steel or aluminum, it's beautiful. So it's kind of beautiful. I don't mean that you have to do it, but it's something that you have to take into account. Do I expose my ducts in my design? And sometimes if you're designing something with an industrial style, exposing ducts, it's something beautiful. Or you can decide to hide your ductwork behind the false ceiling, and you will only see the grills, like this drawing. There will be the air handling unit here, and then we will be designing this ductwork, and we will see only the air terminal. We will see only the grill or the diffuser. This is the air terminal, and we have supply diffusers with this arrow here, and we have return diffusers or grills with this arrow there. And then we have to connect the supply and the return to the air handling unit. So in this exercise, we will be doing something like that. It can be either exposed, or we can use a false ceiling, I don't mind. But we are going to work with 2 different floors, and we need like a shaft, vertical shaft to, yeah, because we need to place the vertical ducts here on this shaft. So we need to dimension this, because look at this, we are losing a lot of space because we have to go down with the ducts here. What else? I told you that even for residential buildings, I think this is a house, this is a residential building. It's something cool, so it can be exposed as long as we have nice materials and things are nice. Everything is exposed here, lighting, the air ducts. So I think it goes well, those fans here. So I think it goes well with this kind of architecture, exposing ducts. Okay, but this is a design decision, and I mean, if you know how to use REvit with this, if you are designing something like that, you can decide that your ducts are exposed, and that will add a value to your design. If you decide that those are exposed ducts. Sometimes in huge buildings or in commercial areas like this can be a Walmart, or so if you visit a Walmart, if you look up, you would realize that there's a universe looking up, that probably is not, people are not aware that we have this above our heads. And we have a lot of things. We have the structure, we have the lighting systems, we have those are ducts. Look at this, they are exposed. And we don't have grills. Those are like balloons, okay? So they are, and you see that we have a lot of perforations. So the air flows and it goes out through these perforations, these elements here. Okay, so there are a lot of things we can do. Sometimes we like it, sometimes we don't. In this kind of commercial areas, there is no point in having a false ceiling because there are a lot of things here, and for maintenance, it's better to have all these things exposed so that if there's a problem, I can fix it immediately. I don't have to remove the false ceiling and then I have to fix it now. I can access everything. So it's not ugly. I mean, it's something that everybody's used to looking up uh, and looking at all these things, ducts, pipes, electric wires. Okay, so if it's exposed, nowadays it's something acceptable. Or we can go for the traditional air ducts, something like this. So if you see when they are exposed, they tend to be round. If they are hidden, they tend to be rectangular. Why? Well, I don't know. Because round shapes are more appealing. I think so, yeah. That when we have rectangular shapes is that we want to reduce the height of those ducts. Okay, so they are rectangular, so the short side is the height and the long side is the width of the duct. You see here, so they are very wide and not that tall, or not that, yeah. And when we hide them, we recover this with a thermal insulation because the problem is that we can have leaks, we can have air leaks, or we can have a lot of heat, or yeah, we can have heat gains or heat losses when the air at high or low temperature is running through those ducts. So from the efficiency point of view, having a false ceiling with these ducts that they are covered with thermal insulation, it's more efficient than having exposed ducts. But for maintenance, this is easier than this. Okay, so again, we need to balance different things. We have to talk to our client, we have to talk to the mechanical engineer, and we have to make a decision, but eventually architects make the final decision. So eventually it's our decision. But we cannot make that decision without listening to our clients or mechanical engineers. And something, we are going to do something like this today. So we are going to place the diffusers, and then we're going to place the ducts, and we're going to connect diffusers to the ducts, and those are horizontal ducts. There will be vertical ones, and eventually we will connect everything to the air handling unit. This is what we're going to do. And then we can calculate things. Okay, so here I have more slides to calculate ducts, but we're going to design our ductwork, and then we're going to calculate it. When we're working with Revit, we can do this. Usually we calculate things and then we design, or then we use the software, the 3D software. And when it comes to mechanical systems in Revit, first we can design, and second we can calculate. Or, well, Revit is intelligent enough, and Revit makes its own calculations. So we have to check what Revit has done. Yeah, so this is the right way to do it. First, we design the ductwork, and we connect everything. We check that we have connected the right things to the right place on the air handling unit. And then we check whether what Revit has done is good or not. So this is what we're going to do. Today we're going to design, and next week we will check if what we have done is good or not. And then once we have done the duct work, changing the size or the ducts, it's easier than, yeah, I think it's easier doing that with Revit. So that's what we are going to explain this year. So it's something new. Well, it's not new, but it's different from what we did last year. Okay. So I have prepared here some guidelines. So we are going to design first the supply system, and then we're going to design the return system. And I have prepared those guidelines. So the first thing you have to do is you have to read these guidelines, these bullet points, and we have to abide by these bullet points. And you'd better don't miss a step, because I think it will be better if we go step by step. Sometimes we tend to do three things at the same time, but Revit is difficult. So we have to deal with Revit step by step until we gain confidence, and then we can do whatever we feel like. But for the first times, I think we should go step by step. Okay, so this is our friend Revit. I'm going to open. If you remember, I created a mechanical template last week. So I can open the mechanical template I created last week, because I have uploaded there grills or supply diffusers or ducts. I have edited the duct type or the diffuser properties. So I have made some work. It's not everything there, but I don't start from scratch if I upload the same mechanical template. So I'm uploading this mechanical, well, the template that I created last time. I open this. I open a new project, not a template. I open a new project. And this is what, well, this is the masterpiece that I created last time. And I have seen that most of you are at this level. If you are not at this level, don't worry, because by the end of this week, you will have to reach this level, and you have to go further. So we created like a box here with here on the elevation. Okay, so there were level 1, level 2, and then we had the roof, but this is the bottom level of the roof, and then we had level 4. Okay, so we placed the air handling unit on level 4, and we placed all these the diffusers and the ducts below level 2. Okay, and then we would have to do the same here, because we have 2 floors. Okay, so let's start with level 1. Okay, so on level 1, yes, well, Tyler and Anthony, I know that you are there, so we'll take your attendance later. So on this first floor, well, first, as you can see, we're working with a mechanical discipline, so we can't edit the walls. Okay, but to be on the same page, we are going to edit walls first. So let's work with an architectural discipline. And when we're working with the architectural discipline, the mechanical systems disappear, and now we have the walls here. Just to be on the same page, and we're all working with the same model, I want to change this. So let's make this 50 feet. Okay, and let's make this, this is 40, so it has to be 50. And I want this to be, let's say, 35. Okay, so we have a rectangle, 50 by 35, kind of. Okay, why? Because depending on the size, we need to place more or less diffusers. So with 50 by 35, we will calculate how many diffusers we want to place. Okay, so I have modified the walls, and now I go back to the mechanical discipline. So we're on level 1 on mechanical discipline. I can get rid of everything here, and I'll start again. So you know that we're in the mechanical discipline. We are clicking here systems, and we will start by using air terminals. So those are the diffusers, grills, or we can place either a diffuser or a grill. What's the difference? well, I don't know, a diffuser, it's something that it's either round or square. A grill, it's something that it's rectangular. Yeah, we can say that. Anyway, we are going to work with diffusers today. So if we place this, you remember that I have inserted the supply diffusers, okay? So make sure that we insert supply diffusers. We are on level 1, and we are on the elevation. Okay, so let's start. Oh, first, sorry, because we have to go step by step, and we have to start calculating the number of supply diffusers. Okay, so the rule of thumb, it's that we need one diffuser or a diffuser each 500 square feet. So this is a rule of thumb. We can have one diffuser each 400 or one diffuser each 550 square feet. But well, if we have to start designing the ductwork, this is a good rule of thumb. So we have one diffuser each 500 square feet. So let's do it. So the dimensions here, if you annotate, align, and we place this dimension, it was 35 times 50. Okay, so this is 35 times 50. So what's the area? The area is 35 times 50, 1,750. So what's the area? The area is 50 times 35. So this is 1,750 square feet. If we divide this by 500 square feet, how many diffusers do we have? We divide this by 500. It's 3.5. We can have 3.5 diffusers. We can have 1, 2, 3, 4, 5. Okay, we need. So we have to round up. This is for diffusers. Okay, if it's 3.2, 3.1, 3.9, we use 4 diffusers. The more diffusers, the better. Okay, of course, diffusers they cost money, so the more diffusers, the more expensive the ductwork will be. But in terms of comfort, in terms of energy efficiency, the more diffusers, the better. So we always round up. Okay, so if it's 3.1, even if it were 3.1, we would use 4 diffusers. So this is the first calculation that we have to make, the number of diffusers. Okay, we know the area of our room. We divide this by 500, and then we round up. So we are going to use 4 supply diffusers. So let's do it. So now we go to systems, air terminals. So we have supply diffusers here, and we have to place 4. Let's say 1, 2, 3, 4. Again, I have placed this randomly. It's better if diffusers are, there's the same distance between all diffusers. It's better. Okay, so how can we do this? We can either do this when we are working with, if we select 2 diffusers. No. Well, we have this reference, but I mean, if we use, and this is something we can use not only to place diffusers, but if we are working with columns or walls and we want all of them to be at the same distance, we can use annotate, align, and we take dimensions from this face to that face, then this one, and that one. Okay, so look at this. This is 11, this is 10 feet 6 inches, this is 12 and 2 inches. And look at this here, we have EQ. So we click here, and all distances are equal. Amazing. Okay. Okay, so by doing this, we can place randomly the diffusers, and by annotating and doing this, okay, if I click here, this EQ, now things are different, and I can move them. Okay, I can move this, and if we want them to be equal again, I click here, and there you go. Warning. Okay. So now we have placed 4 diffusers, and all diffusers are at the same distance. So we are getting, yeah, that's better. What about the east? If we go to the east elevation, okay, so we have placed diffusers here. Is this what we want? No. Second guideline. Well, the distance between supply and return diffusers, minimum should be 10 feet. So we will do this later because we are working now with the supply system. When we are working with the return system, we have to take that into account. Let's say that the elevation of diffusers is 10 feet, and the bottom elevation of ducts is 12 feet. Well, again, this is a rule of thumb. If we have a diffuser here, we need the duct to be 1 foot or 2 feet above the elevation of the diffusers. So now the elevation, if we select this, the elevation of that diffuser is 0, you can see. So we can select all of them, and we can make the elevation 10. There you go. Okay, so now diffusers are 10 feet above the floor level. It can be 10 feet or 11, I don't mind. So I decided 10 because our levels are 0, 15, and 30. Okay, so it can be 11 or 12, or it depends on how much space you have here. That 10, it's good. Okay, so now on level 1, we will have diffusers. If we select this diffuser, we can check that it's on level 1, and it's the elevation from level 1, it's 10 feet. Good. And now we have to start designing the ductwork. So we can go to systems, and we have ducts here. There are different ways to do this. We can select the air handling unit. We can select all diffusers. We can work, we can make REvit make that decisions. But after doing this many times, I don't know, I've found out that this way it's easier because we control what we are doing. If we let REvit do whatever it feels like, then we will have to fix a lot of things, and we will spend more time fixing things that REvit has done than starting doing things on our own. So I think this is better. Anyway, we're going to start placing ducts. And this is very important now because we are working with the supply system. Those are supply diffusers, and you see the arrow is going outwards. So that means that we have the diffuser and the air is going out. So when we are designing ducts, we have to make sure that the system type is supply. Here we have supply, exhaust, and return. So if we are working with the supply system, we have to select here supply. I think by default we have supply, but we have to check that before drawing ducts. Okay, so we have to make sure that this is the supply type. So we can, let's say, oh, and we can control the elevation. So the bottom elevation by default is 9, and we decided it's going to be 12 because this has to be above systems duct. Okay, well, it's 12. It has to be above the diffuser level. So a couple of feet is good. And then, well, this is the design decision. Do we go close to the wall with the duct, or do we go close or in the middle of, I don't know. I'm going here because I feel like doing this. But this is your decision where you place the ducts. And now on the east elevation, okay, there you go. We have the diffusers at this level and the duct above the diffusers. So once we have this, we can either work in plan, or we can work in 3D. We can try different things, and sometimes we will try things and things won't work. For example, I select this one, and I have to connect this diffuser on 3D. I have to connect this diffuser to this duct, okay? And usually we connect this by means of flexible ducts, okay? So on level 1, I select this. I right-click here where that dot is. I select draw flexible duct, and I make sure that this axis is highlighted. You see that here nothing happens, but if I hover the mouse, look, now we have the axis here. So that means that it's connecting this to that. What happens? Well, this is what happens. Is this what we want? No. Okay, don't panic. We'll do it again. And probably sometimes it works. In this case, it's not working. Okay, but you might do this and you connect this to, or we can do this with a repeat duct. It doesn't work. Okay, so if something doesn't work, do not worry. We have to do it in a different way. What if I select this and I right click here, I create the flexible duct, and I try to connect this to the duct itself? Well, now it works. Okay, what if I try to do it with this duct here? Flexible duct. I need to find the axis, so I don't think, no, terrible. Okay, so if REvit doesn't like this way, I have to try something different. So what can I try? I need a connection here, so I need a T, because I need to connect two pipes or two ducts, and then I need to connect a different duct here. So I need a T. So we have elbows. When we have to go to change direction, we have an elbow. But when we have a duct and we have something like that, we need a T. So I can use the systems, the fitting. Here you see the duct fitting. And here we have T's. So I recommend you use, if we are working with rectangular ducts, I recommend you use this rectangular T standard. Here we have different T's. So this is a rectangular to round T, conical tap. Well, we can try different ones, but let's try the rectangular T standard, okay? And we have to place that T here, close to this, okay. What's the problem now? So the problem is that we have this connection. So the connection should be at this side, because we have to connect this diffuser to this duct, and the connection it's there. We can use this rotate. You see that there is a tiny circle here. So this is rotate. So we rotate once, we don't know what happens. We rotate twice, and now this is the place, and this is the connection. Okay, where the dot, this is an intelligent dot here. So this is a connection, and as you can see we have another dot here. So by connecting these two dots, it will work. Will it work now? I don't know. Let me. Okay, so here we have the T. This is the diffuser. Can I connect now? Can I right click here, draw a flexible duct, connect this here? Will it work? Yes, it works. Okay. So if this doesn't work, if I click here, draw flexible duct, and then I try to do this, well, I don't know why, but this doesn't work directly. So I think I have to place more T's here, and then we can do this many times. But first, I want to check whether what we are doing is right or wrong. And apparently is wrong. Okay. So this has not worked. Let me try again. So I will draw a flex duct. Let me try level 1. Flex duct here. Okay, now it's working. Okay, now it's working, but before it wasn't working. When I had this, okay, it seems that it's connected, but it's not. So how can I find out if this connection is good or not? Well, if you click on the diffuser, you see that we have different information about the diffuser. And the most relevant information is the mechanical flow. You see that the flow, it's 500 CFM. Where does it come from? Well, we should know the CFM of our diffusers. So look at this. We have this drawing. Okay, imagine that we are on the first floor. We are designing this. We agreed that we need 4 ducts. Here, this is a schematics, so we have only a diffuser, but we need 4 diffusers. And what is the flow of each diffuser? We have 100 plus Y. So let's say that we have 150 people. I don't mind, okay? So imagine that we have 150 people. If we have 150 people here, we have to calculate the CFM of each diffuser. So if we have 150 persons times 20 CFM per person, what is the total airflow that we need in this? So the total airflow is 150 times 20. It's 3,000 CFM. So all of you will have different CFM because that depends on your ID number, okay? But we here in this example, we have 3,000 CFM and we have 4 diffusers. So we have to divide this total CFM divided by 4 diffusers. Why 4? Because 4 diffusers is what we have calculated here. So this is 3,000 divided by 4, 750. CFM. Okay, so this is the second thing that we have to calculate. The CFM that we have in each supply diffuser. And now we can change it. In REvit, where's REvit here? So if we click here, this is not 500. This has to be 750 CFM. Okay, so when we click here, we have to make sure that this is 750. And we have to change all of them. 750, 750, and 750. Okay. So now if we check things are going well or not, if I click here, what would be the flow of this duct? It would be 750 because if this diffuser has to have 750 CFM, the flow through this duct should be 750. So here we can see that the flow is 750, so it's correct. So this is 750 as well from this diffuser. In this duct, The flow is 750 as well. But if we are adding up these two flows, the flow here should be double, should be 1,500. If we click here and we see that the flow is 0, that means that there is not a good connection. So there is something wrong here. You understand? So probably this is wrong. Because now if I click this, it's still 0. Well, it's still 0 because here we have a T and this side is open. So we have to close it. So we have to connect this with this. So let's try to do it again. Let's click here, draw flex duct, and it's not working. I don't know why. Sometimes you are trying working with a 3D and it doesn't work. Sometimes but if it doesn't work, you can do the same with the plan. Okay, so we are going to connect this flex duct, and we have to connect this. So now at least we have the point here. So we connect this, we go to the 3D, and something has changed here. So now we have this transition between the round duct and the T. I think now it's working. So if I click here, yeah, if I click here, I see that the flow is 1,500. Okay, so it's we have to check that this is working because we are not calculating anything. We are making Revit calculate things on its own. And one of the things that we have to calculate is the flow, the airflow through the ducts. But here, if we have only one diffuser, the flow here should be 750. If we have two diffusers here, the flow here should be 1,500. If we add a third diffuser and a fourth diffuser, finally the flow here should be 3,000 because this is the total flow in the room. Then we lose part of this flow, then we lose, and at the end we only have 750. Okay. So what can we do? We can try to do the same here. So let's do this. So I'm going to do this in different ways to see if it works. Okay, so definitely today Revit doesn't allow me to work in 3D. Okay, I don't mind. So let's go to level 1, and we can do the same thing we did. We can go to systems, we can go to fittings, we can insert another rectangular T here. We can rotate that T because the connection is in the other side. So we rotate here, we rotate, and now connections are on the same side. And now I can select this, I can click flex duct, I connect this, and I think now it's working because we have a connection here. So let me check this. So it will be working if I select this duct, and we have 3 times 750 because we have 3 ducts. Okay, so here the flow is, yeah, it's working because it's 2,250. Okay, so finally I have to go to fittings. I can select the same thing here. I rotate it, rotate 1, rotate 2, okay, select flexible duct, and there you go. And finally, on this duct, there should be 3,000 CFM. Yep, there you go, 3,000 CFM. It's working well. Okay, so this is something that we have to check. We need to check that our connections are good, because if something happens here, for example, if I remove this connection, okay, it might seem, oh, okay, it seems that it's that everything is connected. but then I check this and I have 0. So there's something wrong here. There's something wrong because this connection is not, or it's not there. So now I click here and I see that it's 1500. So that's working well. So we have to be careful with this because from the architectural point of view, it doesn't matter. If you just want to take a good render or a nice render of this ductwork, this connection is not relevant. But if we want to calculate the airflows and the heating loads and all that stuff, if it's not well done, things are not working well. Okay, perfect. So on our east elevation, once we have done this on the first floor, I can select everything. I can copy and I can go up. Okay, so I don't have to do it again. So once we have done the first floor, the second floor is a piece of cake. But I would check whether the airflow here is 3000. Yes, it's 3000. So it's working well. Now we have to connect these two ducts vertically. And how can we do that? Well, if we are working with vertical ducts, I have to use elevations. Okay, so now I want to go up. So if you start here, you right click here and draw duct. If you go up, let's go up. Up. So here we have the elbow. And why do we have this elbow? Because if you remember, I have edited this type, edit here, and the elbow by default is the rectangular elbow. Well, by default is none, okay? So when it's none, you don't have these connections. So we decided that we were going to use this rectangular elbow. Okay, so that was our default. Our preferred junction time, we have a T. Transition, we have none. Probably this is the problem. That's why when we are trying to insert a flex duct on this, we don't have, because this is none. So I'm going to select rectangular transition. On junction, I would use rectangular T. Okay. And I will apply. So probably next time it will work. If we have a diffuser and we just connect this, I have declared that I want this rectangular T, so there will be a transition and I don't have to do it. But anyway, I don't mind. Okay, so we have this. What's happening here? Okay, so we might think that this is well connected because, okay, so it's here, it's there. So is it connected? And now we have to check the airflows. So if we click here, we see that the airflow here is 3000. It makes sense because this is 3000. It's 3000 here. Okay, so if I click here, it's 3000. But there's something wrong here because this is 3000 as well. So if I click this, it's 3000. So this part of the duct should be 6000 because I'm connecting 3 plus 3. So that one should be 6. And it's not. Okay. So there's something wrong here. So there's something wrong because this connection is not well done. Okay. So I think if I work with the east elevation, I drag this until the axis. Okay. Let's see what happens. It works. Now that I have declared that I want a T, a standard T, rectangular T, when I connect this and this, I have a standard element. So now we connect these two. And if this is a good connection, the airflow here should be 6000. So let's click this, and yes, it's 6000. Because this is 3000, 3000. This one is 3,000. Yes, it is. So if I connect two pipes with 3,000 each, they should be 6,000. Okay, so it's working. Okay, now it looks good. And now I have to connect this to the air handling unit. So if we analyze the air handling unit, you can see that there are a lot of things here. When we have this square, this is an air duct. So if we click here, you see that we can read create duct. So here we have another duct, create duct, okay? And even here, this one, it's another duct, okay? So we have three ducts here. And what is all these things that we have here? So this is create a pipe, okay? So this is for water pipes. And these are the cooling and the heating coils, okay? So this is the inlet and outlet, because this is the heating and cooling coil, and this is for the air duct. So we have three elements for air ducts, and we have 1, 2, 3, 4 pipes, and this is for drainage. Okay, so this is another pipe, but this is for drainage, because we can have condensation inside this air handling unit, and we have to get rid of water. Okay, so today we are working with ducts. We are not working with pipes. So let's work with ducts. But what duct do I have to connect this? This is the supply system, okay? And what is this? This is in. If I want to connect a supply duct to the air handling unit, I don't need the inlet, I need the outlet, because the air is going out the air handling unit, and it's going through the supply system. So if this is the this is the outlet, we can understand that if we look at the roof, okay, this is the outlet. And if this is my supply system, it's just the other way around. I have to rotate the air handling unit. Okay, let's rotate it. There you go. And now the outlet, it's on the right position. It makes sense, okay? But now this outlet is 54 by 40. Okay, so we can always click here. Okay, so this is the outlet. We click here and we can draw duct. And we have a duct. Okay, and this duct is 44 by 40. And what about the size of this duct? This is 12 by 12. Well, I don't like it, okay? And so we're not going to do this. And we can edit the type. The good thing in Revit is that you have this default air handling unit, but now you can make your own family or your own air handling unit. So we can edit type. So we select this, we edit type, we can duplicate, okay? And I'm going to name this, let's say, Fernando air handling unit. Okay, so I have created my own air handling unit. And here I have, this is the supply air outlet and the supply air width and height. So I can modify supply air outlet, because this is what now it's 54 by 40. I think it's too big. I think in this case, 20 by 20 would be enough. 20 by 20. So we click OK, and you see that this has changed. Now this is 20 by 20. See, this outlet is 20 by 20. And now we have to connect this to that, and it seems easier. Okay, but anyway, it will be, we can go to the roof level. We can start, we can right click here, draw duct. So we can go this way. You see that Revit is intelligent. So when we are on the same axis, we can do this. Okay, now it can go this way. And I can, by default, I have this elbow. So on the 3D, okay, I have this and that. What will happen if we connect this and this? We need an elbow, and then we need a reduction, because this duct is 12 by 12. Okay, this is 12 by 12, and this duct is 20 by 20. So if I'm working with the roof, I click here, I drag it until this dot here, the pointed vertical. Let's see what happens. Do we need this? No, we have to get rid of all this nonsense. And okay, so that's interesting, because here we have a T. Okay, so you can see that, by the way, we have a reduction here, so it has reduced the duct size. So we have this fitting. So this is a rectangular transition. Okay, so it's a rectangular transition from 20 to 12. Is it good? Yeah, but here we have a T. Okay, so let's look at this. What should be the airflow here? It should be 6,000, because we have 3,000 and 3,000 here. So if I click on this transition, we don't have it. What about the duct here? Okay, again, this is 0 CFM. So there is something wrong here. And what is wrong? This is a T. You see that we have 3, 1, 2, 3. So this is open. And here we have a tiny minus. So if we click here, you can see that we have elbow. So if I click here, I turn. Okay, I can't do that. But I should turn that T into an elbow. The problem is that we don't have that P, so we have to modify this this connection. How can I modify this connection? Sometimes those elbows, I need more space to modify those elbows, okay? Because the elbow, it has a, if I have this, I draw duct, and okay, I will work with the plan, because I think it's easier to explain. I'm going to do it again. So imagine that I'm working with this, I draw a duct, and if I go this way, I have an elbow. And if I go this way, I have another elbow. But what if I want to do something like that? It's not possible. So I cannot have another elbow here, because these elbows have, they need this dimension. Okay, so I need to continue this, and then I can draw this elbow. So sometimes when we have things that they are too close to each other and we try to create an elbow, it doesn't work, because the distance between this and this, or the radius, it's not enough. Okay, so this is what's going on here. It's not going well, because I'm forcing this, so I have an elbow, and then I have to go down with another elbow, and I don't have enough space. So usually these things work better when we simplify things. So the fewer the fittings, the better. So why do we have a horizontal elbow and then a vertical elbow? What if I have just a vertical elbow there? It will be easier. It will be more effective, and it will be easier for Revit and for the workers that are working with this. So I have to change that design. So on the east elevation, I think I can move all these. No, I don't like it. Okay, let's do it again. But now, I know what to do. So I need to go from the air handling unit downwards, and then I have to connect the vertical duct to those horizontal ones. Okay, so no problem. I can open the south elevation. So on the south elevation, I have this level of detail. Okay, so I know that I want to draw this duct. Here we have the axis of this horizontal element, and now I can go down. There you go. Okay. On the 3D, yes, I go down here, and now on the east elevation, I can connect this and that. So I have a nice connection here. And what about now? Can I go here and connect it? And if I go down and I connect this, okay, it works. Okay, so I have simplified the ductwork, and this is good. This is what we have to do. We have to simplify it. Before I had this, then I had a horizontal elbow, and then I needed a vertical elbow, and it was a mess, and it didn't allow me to do that. Now I just have a vertical elbow and go down, and I need these two connections. I need this connection between this and this, and I need this connection between this and that. So I have simplified the ductwork, and now it's better. Okay, because we are reducing the time, because connecting all these ducts in the real life, in Revit, it takes a couple of minutes. But in real life, people have to be cutting the right length, then they have to connect the duct and the elbow. So it takes a lot of time. So the fewer the fittings, these elements, the better. So we can design this with Revit, and even designing simple Revit ductwork, it's easier than complicated Revit ductwork. Okay, so we have to reduce the elements, and this is what we have done here. Okay. And now the most important thing is that if I select this, the flow is 6,000. So now it's working well. So there is all connections are good because we have flow in every single piece of duct. Because if connections are not good, we don't have any flow there. So that means that we have done something wrong. Okay, this is the supply. So if we are done with the supply system, now we can start designing the return. And well, now that we have done this, return is a piece of cake. Why? Well, these are the step-by-steps. You have to insert rectangular T standard. You have to connect all supply diffusers with flexible ducts. I will type it here, flexible ducts. And finally, you have to connect everything to the air handling unit with a vertical duct. Okay. What about the return system? We have to do the same. We have to calculate the number of return diffusers. Usually, we have the same number, we have the same supply and return diffusers. It can be different, but why? If we have calculated the supply diffusers, we can have the same number of supply diffusers. The second, the distance between supply and return diffusers, the minimum should be minimum. It should be 10 feet. Why? Well, because if we are, do I have a drawing here? No, I don't have drawings. Well, if we have if we have a supply diffuser too close to a return diffuser, the air can go from the supply to the return diffusers, and we want the air to stay in the room, and then it can return through the diffuser. So the farther, the better. Okay, 10 feet should be minimum. In this case, when we have a rectangular shape like this one, it's quite easy because here it's 35. Okay, so the distance between the supply and return diffusers should be, yeah, it's going to be more than 10 because we have a 35-foot room. If, well, with a different room, it will be different, but let's keep it simple. And now, what do we have to do? We have to insert air terminals. But look at this, on the air terminal, we only have supply diffusers. Okay, I didn't load return diffusers last time. So the first thing I have to do, I have to insert where is insert? Here, insert family, and on that family, it's in the US Imperial, mechanical, MEP. So that's the difference between the architectural and the MEP things. In architectural, we have the same thing. We have air terminals, we have diffusers, and we have all that stuff. But it doesn't calculate the airflows. So when we are working with architectural models or 3D objects, it doesn't calculate the flow. So we are not, it's the professional thing, it's working with the MEP, that stands for mechanical, whatever. So here we have the airside components. This is air terminals. And no, it's not. Oh yeah, it's the air terminal. So we have supply diffusers. And as you can see, we have return diffuser. Okay, so we have to select this one, open. And now if we are uploading here, we have the supply and the return. Okay, so this is the return and this is the supply. So let's select this one. And as you can see, the symbol is different. Okay, so look at the supply and the return diffuser. The supply, the arrows are going out. In the return, the arrows are going in. And here we have like a cross, and here we have only just a line. So we can differentiate whether we have supply or return diffusers. We have to control the elevation. We agreed that it has to be 10 feet. Okay, and now we can either insert diffusers or we can copy. Yeah, so probably we can copy diffusers. Okay, I'm going to try something different. I'm going to copy another diffuser here and another one there. So things are better if they are aligned. So I can use the align tool. Okay, if I use this align tool, I can select this face and that face, they are aligned apparently. What about this one and that one? Okay, now they are aligned. This one and this one, okay? And finally, align and align. Okay, if I want to move them up, something like that. Okay, now I'm going to make a mistake so that you can understand why making mistakes it's not recommendable. So I'm going to work with systems. I'm going to work with ducts. Okay, and now this duct is a supply air. So I don't change the system. So I just use the supply. And I place the supply here. So first, where is it? On the 3D? Okay, because I didn't control the elevation. So remember that. So the elevation is 36. It has to be 12. Okay, so now it's in the right place. So on the first level, I can see this. But what if now I try to connect this with a flexible duct to this? Apparently, it's working. Okay. Well, this is a 20 by 20. Yeah, I will change it because I want this to be 12 by 12. But apparently, this is working. But only apparently, because if I select this, by the way, the CFM, it's 500. If I have the same number of return diffusers, the airflow should be the same. So here should be 750. This should be 750. All of them should be 750. Okay, so now I click this. The CFM is 750, it's okay. If I select this duct, the flow is 0. Why? Because we have connected a return diffuser to a supply diffuser. And okay, but the fitting is correct. I have this transition. So why? Because if we look at this, this is supply air, and this is a return. Yeah, this is a return diffuser. So I can't connect supply and return elements. So if I draw a flexible duct, it's not working. Okay, so we can either, well, let's undo what we have done. So if I select this, I can change the system type so it can be returned. Okay, so now it will work. Well, I will change the width, so that will be 12 by 12. Okay, that's better. And now if I select this one, I select flexible duct. I connect this, and if everything goes well, I select this here, and now it's 500. Well, it's 500 because I undo, so it has to be 750. This has to be 750. This has to be 750 and 750. Okay, I click here and this is 750. I click here and it's 750. Okay, so now it's working well because the connections are good and the systems are the same. So we have return and we have return. Okay, so be careful with that because we tend to make mistakes. And then that's why checking things, if we go step by step and we check that we have done is correct, it's the best, because if we are working for a couple of hours and then we start checking, so where's the mistake? We don't know. If we connect this to this and then we check the airflow, we can understand where the mistake is. Okay, so I'm on level 1. Will it work if I select this and this? Is it working? Well, not really. So I'm going to insert a fitting, a rectangular T, and I'm doing the same now. I am creating a flexible duct here. Okay, that's better. To make sure, I click here and it should be 750 plus 750. So this is 1500. Okay. So now I can insert another fitting. here, and finally I will insert another fitting there. Okay, now I select this, draw the duct, and I select this, draw the flexible duct. Okay, so if everything is correct, the airflow here should be 3000. Let's click 3000. Okay, so all connections are correct here. Okay, so on the south elevation, I can see the supply, I can see the return, I can select all these, I can copy. There we go. So now we have to connect the return inlet to all these ductwork. So we can do exactly the same. So now we have to check the air handling unit again. Okay, so that was the outlet, and there are two inlets here. Okay, so what is the here we have inlet, and here we have an inlet. So what is the right one? Well, we have to find out. So if we select the air handling unit, we have two inlets. We know that there's an fresh air inlet because we need to take fresh air from outside, and we have to return. Both are inlets because we are from the return, we are going to the air handling unit. From the air handling unit, we go out and we supply the air, but then we return the air and then we go in. So we need an inlet here. So it can be either this one or that one. Well, here we have a hint. Here you see that we have only this. Okay, so we have this, we have only one bar here, one slash or whatever. This is the right symbol because on the return diffusers, we only have one line here. We don't have two lines. We don't have a cross. We have only one line. So most likely it will be this one. But to make sure, we can edit the type. Okay, so if we edit the type, here we have the supply air outlet. And here we have the supply air inlet. So the supply air inlet is the fresh air that we take from outside. And we have the return air inlet. So this is what we need now. We need to connect the return duct to the return air inlet. And the width is 50 by 60. So let's change this. Let's make it 20 by 20. Okay, so we have, you see that we have, well, we have changed both. But this is the return inlet. Okay, so but it's here, it's at the top of the air handling unit. So we have to go up, then we have to go rightwards, and then we have to go down. Okay, so let's do this with the south elevation. So we click here, we have to draw duct to go up, then we have to go this way, and then we have to go down. But instead of going down here, I think I should, yeah, so I will leave it that way so far, because on the roof plan, okay, okay, I can use the top here, and now I see this. Okay, so I have to drag this until I found this axis here. There you go. And now in the south, I can continue to draw the duct, and I can go down. Okay, So now finally on this east elevation, I can connect this return to this. Hopefully it works. And now I can connect this to this. And it works. There you go. And if we have done everything correctly, the airflow here should be 3,000 plus 3,000. It should be 6,000. It is 6,000. Okay. Isn't it beautiful? I mean, Revit might seem complicated and yeah, it's a nightmare and sometimes it doesn't connect things and the flow is not working. But doing things by hand, believe me, it was a nightmare. When I was a student, I had to do these kind of things and I hated it. And but Revit is wonderful because you can do this we have been doing this for an hour. So it can take days to do this, calculating this by hand, then drawing it without a CAD, without Revit, without a 3D model. It took forever. And now in a couple of hours, you can do something quite good. And at the same time, you are making calculations. We are not talking about the air speed and all that things, but I think we are good because every time we connect two ducts, we are adding up the CFM. So everything is working now. So we are ready not to calculate, we are ready to check whether Revit calculations are good or not. Okay, if they are not good, we can fix it easily. But next week, we will check whether those calculations, whether the airspeed or the sizes that we have chosen are correct or not. And if they are not, we can change it easily because the basics it's here. So it's the layout of the system is here. Okay, what's next? So that would be today's assignment. So I will post something on Canvas. Try to do this. So we only have to complete the supply and the return system, and we have to connect this to the air handling unit. If you can do this, you are above the average when it comes to working with Revit. Okay, nobody knows how. Well, nobody. Architects usually don't know how to do this with Revit. So if you know how to do this, you are above the average. Even if you don't know anything about Revit, you can. If you only can create walls and the roof, this is what we did for modeling. The So if we just have 4 walls and the roof, but nobody can do this with Revit. Okay, and if you start learning this today, the rest is a piece of cake because this is basics. Then we can complicate things. We will have more diffusers. There will be a bigger building with different rooms and probably more than one air handling unit. But if you know how to do this, it would be great if by the end of this course you end up knowing how to create 2 systems, the supply and the return. That's more than enough. Then we are not stopping here because we can insert more things. Okay, so if we insert more families, this is not the air terminal, but we can go to the water side components. Okay, so on the water side components, we have the boilers, the chillers. Let's explore. Okay, so here we have boilers, chillers, pumps, cooling towers. Okay, so if you open cooling towers, we have a few cooling towers here. Okay, so select the, yeah, I think this one is the smallest one. So we can open And now if we are on the roof, if we connect or if we select systems, mechanical equipment, there's a cooling tower here. It's another monster. Okay. But on this cooling tower, whoop, okay, so on this cooling tower, as you can see, we will have inlet and outlet. So those are the pipes, the water pipes that we need to connect to what? The cooling tower, as you should know, it has to be connected to a chiller on the basement. Okay, so are there chillers? I'm sure there are. So we insert load family. These are cooling towers. Yeah, we have chillers. And we have water-cooled chillers. These are the kind of chillers that we saw on the video. And we have air-cooled chillers, this one. Okay, so if we're using an air-cooled chiller, we don't need a cooling tower. If we're using this water-cooled chiller, we do need cooling towers. So we can open this, and then on the systems, mechanical equipment, so we can place this somewhere here. Okay, and well, it's not on level 4 for sure. It should be on the basement, so we can copy another level. We can create a basement. This is level 5, and then we can place this on level 5. There we go. Okay, and then we will have to connect the chiller. Well, we have to place the chiller on the right position. We have to connect the chiller to the cooling tower, and then we have to connect the chiller to the cooling coil of the air handling unit. Okay, but we can, because here we have the cooling coil inlet and outlet. On that chiller, there should be, yes, there are inlets and outlets. So one of these will be connected to the cooling tower, the other one will be connected to the air handling unit with pipes. Okay, so it's the same. We're not talking about piping systems yet, but if you click here, you right click, draw pipe, and you can start drawing pipes. Okay, so eventually we have to connect this to the I don't know where this is. I'll find out. Here. Okay, so we have to connect these two dots, this one to that one. So once we have the families and this, it's just connecting dots, and that's easier. So it's not difficult. Okay, but today I just want you to Yep. I just want you to work with this. So this is the final outcome today. Let's try to create a nice supply system, a nice return system, and we are connecting this to the outlet and this to the return inlet. And that's it. And why are we doing this? Well, we are doing this because someone, visionaries in the 70s, they, I don't know, have you heard of that building? The Georges Pompidou Centre de Paris, in Paris. Okay, I'm sure if you haven't heard of it, well, I remember that this building, it made a lot of noise because it was built in the middle of Paris, and they came up with this this. Okay, so nowadays we have seen a lot of things, and it doesn't look like weird. But in the 70s, in the middle of Paris, coming up with this idea, it was like, what is this? This is the most terrible thing I've ever seen. So it created a lot of controversy. So it was controversial. But what did they do? They didn't use, or they didn't hide the pipes. Look at this. So there are ducts, pipes everywhere. Okay, and they painted it with colors. And well, now we are used to looking at buildings like that. Okay, so everything is exposed. The structure elements, the elevators, the staircase. So the staircase, it's outside the building. So at the beginning, people didn't like it, but now everybody considers this like an icon in Paris. Paris has a lot of icons. Yeah, why not? And people don't go there to see modern art. Modern art is bullshit. People go there to see the building, okay? Because this is something different, and it was something visionary. And okay, so look at this. Okay, so this is Paris. So in this neighborhood with Gothic churches and Gothic architecture, they came up with this monster. And look at this, they are showing the air handling units, the refrigeration towers or the cooling towers, and they painted it with colors. Okay, so they didn't hide all these things that before this building, everything was hidden because people didn't want to see all these ugly, well, they are not ugly, or they are, but they don't mind. Well, this is in Paris. So. Okay, but here, close to this nice Gothic church, we have this with colors. If you analyze this building, you can see that there's not a big difference between Gothic architecture and this kind of architecture. They have the same concept. I'm not going to talk about this today, but now everybody loves this building. And at the beginning, it was something that they were about to tear it down, because now Paris doesn't deserve a building like this. Paris is the most beautiful city on earth, and this is a monster with colors and ducts and pipes. Now everybody's used to, with the Eiffel Tower, it happened the same. In the 19th century, they were going to tear it down because nobody liked it, and now, well, France is a weird country. But anyway, the architects of this building, Richard Rogers. This is from the United Kingdom. I don't know if it's from England or Scotland, or I don't know, but he's from the islands. And Renzo Piano, Italian. Both are Pritzker winners, so they are in Gianfranco Franchini. I've never heard of him. Anyway, these two guys are interesting if you want to know more about them, especially Renzo Piano. I think he's like 90 years old now, and he's still working. And when you Google Renzo Piano and you don't see buildings, you see his face, that means that he is important. Okay. Okay, it's interesting. Everything he has done, it's interesting. It's unique. Rogers. Is he still alive? Well, yeah. I don't know. I prefer Renzo Piano because this is too technological for me. Anyway, but probably we are, if we are doing things like this nowadays, or things like that, it's because there were visionaries like 40 or 50 years ago that decided that ducts are something that are not ugly. We don't have to hide them. It's beautiful, so let's show them. And at the beginning, everybody thinks that you are crazy, but at the end, everybody accepts your visionary ideas, if they are good. So be careful with being visionary, because sometimes you can make terrible mistakes. But anyway, it's worth trying. Okay.